Okay, so in order to graph a function rule, remember a rule is just an equation, okay? In a minute we'll use the graphing calculator, but if you don't have a graphing calculator, your best bet is to make an XY table, okay? And so what I mean by that is you start with X, all right? And now what I usually teach 8th graders to do when I teach it in there is I leave a space in the middle to do the work, but you can do it on the outside. And then I do the Y over here like this. And now what confuses kids sometimes when they're going to go graph is they're like, well, what numbers do I use? If they don't tell you what numbers, you get to pick any numbers. So what my recommendation is to pick kind of easier numbers, but you want to pick something in the negative, maybe something at 0 and something at positive. So I'm just going to go with like -2, 0, and +2. That way I have a relatively easy negative, I've got a 0 spot, and I've got a positive. And the reason I leave space in the middle is this is where I'm going to do my equation. So it tells me to get y equals -2x plus 1. That's the equation that I'm using. And so what you do to get your y value is you plug in what you've chosen for x. So we're going to do -2 times, and then our first value we picked is -2 for x, plus 1, right? So then you can use order of operations, right? What's -2 times -2? +4 plus 1. 5. So what this really gives you, right? XY, it gives you an ordered pair of -2, 5. X, Y, right? And you would then put that on a graph. Okay, so then we do it again. But in order to make an accurate graph, you need anywhere from 3 to 5 points. Okay, so we're only doing 3 so I can show you, but so 0 now was the next one we picked. So we just take the equation, which was -2, and then instead of x, we're going to put in 0. So times 0 plus 1 is 1. Yep, -2 times 0 is 0, plus 1 more is 1. So what's the ordered pair? 0, 1, yep. So then you would put that on the graph. 0, you'd go up, left and right 0, and up 1. All right, last one. Does anyone know what I would write in the middle here to do my work for that last one? Carla, go ahead.
-2 times 2 plus 1.
Perfect. Okay, and so this is where like you need to know your math skills or at least use a calculator. What is -2 times +2?
-4.
-4, yep. Then plus 1. -3. So what's your ordered pair? 2, -3. And so it says that we needed to graph it. So then you would put that on the graph, which I'm not going to do by hand, right? But what I am going to do, so you can look at how long that takes. What did that take us? 3 or 4 minutes? Here's why using the graphing calculator is super helpful. Watch, if you take this, right, turn it on. Okay. Does anyone remember from before break? What do I do to put in a function rule? What do I press? Go, David. Press y equals. Now, if you have something in there, you want to clear it out, which I had something in there. So press clear to get out any equations. And then I want to put in this equation, -2x, -2x plus 1. And then what do I press?
Second table.
You can press second table to see if your stuff is right here, can't you? So second table will give you the table. Let's see. Is -2, 5 on there? Yeah, and then it gives you the one in between, -1, 3, 0, 1, and then the next one 0, 1, -1, and then, yep, 2 -3s on there. But what we want is the graph, right? So press graph. There's the graph. Okay, and so when you are graphing and you're using the graphing calculator, okay, you can either keep it like this, And then you want to make sure you've got your X and your Y axis when you're doing your graph. Okay, if you're going to use your calculator, you want to make sure you're accurate in a couple of places, right? And so what you want to do, if you're drawing it by hand, 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 3, 4, 5. Here's where you want to be accurate, right? So when you go back to your table, you want to have a couple of points on it. Specifically, you want to make sure you've got your y-intercept, which is 0, 1. So that's going to be a dot right here. This is where it hits the y, is at 0, 1. And you can see that on here, right? Has anyone realized that if you press trace, it gets on your graph and it gives you, oh, that's at 0, 1. And then you can use your arrows. Now, is it easy or hard to graph 0.42553191, comma, this? Is that easy or hard to graph that? Hard, which is why you wanted that use your table, right? So 0, 1, and we got those points, -2, 5. So left 2, up 5 would be a point there. And then +2, down 3. And using your graphing calculator, is that a linear or nonlinear graph? Linear. And so then you just draw your line through it. That's how you graph it. So the good news is, right, you get to skip all of this if they don't ask you for it, and you can use a graphing calculator, right? You can get the table from your graphing calculator and then get a picture of the graph and then just do it. Does that make sense? Perfect. Okay, now, of course, there's always a lot of real world stuff and a lot of story problems on all of these big tests. So here's our first one. And they use this when calculating stuff in the real world, okay? So it says the function rule, W equals 146C plus 30,000 carries or represents the total weight W in pounds of concrete mixer truck, one of those ones that sort of spins in a circle as it drives, that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet cubed, what's a reasonable graph of the function rule? Okay, so this time, let's do this. Let's use our graphing calculator. So in this case, press Y equals, all right? Now, is W really X or Y here? Y. That's right. Okay. So if it helps you, you can rewrite this to make it 146x plus 30,000. But realize that Y is your W or your weight, and X is your cubic feet of concrete that's in there. So the more concrete that's in there, what's going to happen to the weight?
More weight.
It's going to be more weight, right? But 30,000 is your y-intercept. How do I know that? Or your starting amount. And there's no variable. And how do I know this is linear right away before I even look? Not no negatives. There's no exponents. This is in y equal mx plus b, isn't it? Right? So this is our b. This is our y-intercept. What's our slope? This is our slope, right? Okay, so the y-intercept in this case, right? It's not the weight of the concrete. What's this the weight of? 30,000. It's our starting amount. So think about this. We're talking about a concrete mixer truck, right?
The truck.
This is the weight of the truck. But there's no concrete in it. And then this right here, right? Per cubic foot of concrete you're adding in, how much is it adding of weight? 146. Okay, so let's put this in. Y equals, clear that out. Now we're going to put it in 146x plus 30,000. Make sure you got enough zeros in there. Okay. Now press let's go to table first, right? And so take a look at these numbers. They're really big, aren't they? And we got to get all the way up to 200 cubic feet, right? And that is our X or our Y value, the 200. Cubic feet is X, right? So our X value has to get all the way to 200. So let's press graph a second. What happens? Nothing. Because look at our window. Most of you didn't change your window from when we were working on other stuff, right? Our window is only up to 10, isn't it? So our X value has to go all the way to 200 at least, doesn't it? Right? Because that's the maximum capacity of the truck is the 200. So our X maximum, let's change that to 200. All right. What's the minimum amount of concrete you can put in there? 0, right? It's going to be 0. Can you put negative concrete in a truck? No. So make the minimum 0. Now, does it make sense to go by a scale of ones? What would be a better scale? At least 20 or 25 maybe. All right. I'm going to go by a scale of 20s. Now our Y minimum, remember our Y stands for the weight. Can we have a negative weight? No. So our minimum, we can make that 0, right? The weight of the truck itself is 30,000 pounds, right? But we're adding weight to it. So what do you think maybe our maximum should be? Yeah, let's try 40,000 to start out. Does this make sense to go by ones?
No.
Absolutely not. What would be a better scale? Thousands, at least thousands, right? I might even go by 5,000s here. Oops. 40,000 to start off. And then you can always mess with it, right? All right, now press graph. Does that give you an accurate picture? Because we want to know way out here what it's going to be at 200, right? So what scale needs to be bigger? The X does or the Y? Do I need to? I need to see more Y. So go back to window, right? And instead of my Y maximum being 40,000, what's a better one we maybe want to try? Okay, so let's try 60. Yeah, like to get it accurate. All right, let's see if that works. Did that give us the full picture? It did, didn't it? Right? Okay, so it says, so in here it says what is a reasonable graph? This is a reasonable graph, isn't it? Because it shows the whole picture all the way to 200. Now, this is how you draw this accurately, okay? So we're going to draw the picture like this, all right? Do we need the negative quadrants? We do not, all right? So we're going to draw our picture without the negative quadrants, right? The X values are really our C values, right? So this is cubic feet of what?
Cement.
Concrete or cement, yep. Our Y values, what are we talking about? The weight, yep. All right. And then what was my scale going by? What are each of these little dots is what scale did I choose? 5,000s, right? So 5,000. And you want to at least label every other one. Maybe I even want it to go by 10,000 to make this a little easier, right? Can I do that? Yeah. All right. So this would be 10,000. So when you label ones that are like real world stuff, you want it to be really accurate. So you got to label your scale. We don't know what you're going by here, right? 30,000, 40,000. Oh, I got to extend mine a little bit. 50,000. And what did we go up to? 60,000, right? Okay. And then what did we go by down here on the X's? Nope. We went by 20s, didn't we? Yeah, we went by 20s. So I did. And you can count how many we have here. 20, 40, 60, 80. We went all the way up to how much? Yep, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. And so that's what we want to label it to. Okay, what do you think our important dots are going to be?
30,000.
Yeah, the starting amount right here. We know the y-intercept is 30,000, right? Where else do you think might be a really important spot to figure out? The end, right? What's the end going to be? What are we looking for in our table, right? What number? What x value are we looking for? 200. Okay. We can either scroll by a lot, right? Because I'm a way down at like -2. Or I can go to table setup. Okay. So press second window. See it? Second window. Table setup. This little triangle means change in table. So right now our table is going by ones. Would it be helpful to make our table go by 20s, just like we have it going by here? Let's do that. Make it go by 20s. Now press second table. Oh, and it started at -2. Sorry, second table set. I want it to start at 0, right? Because it's starting at 0 and go by 20s. Does that make sense? Okay, now press second table. Now it's going exactly by what we need it to go by. So depending on what it asks you, we have the ordered pair. At 20, it's 32,920. So we could put a next dot in and a next dot and a next dot and be super accurate. But what the ones that we really want to be accurate on, maybe halfway through at 100, were 44,600, right? So we can put a nice dot right there about where that goes. And then at 200, at the very end, at its capacity, it's at 59,200. So we're way up here. So that's the maximum capacity of that truck. How much can it weigh?
60.
Nope. The maximum capacity, yep. Max weight of that truck is 59,200 pounds, isn't it? With the truck itself and all the concrete in it, that's how much it's going to weigh. And you connect it because all of that is poundages in between. Have any of you ever seen on the side of the highway the weigh stations? Like where you have to have trucks have a weigh station on the side of the highway? They have a max capacity that they can be carrying, and they do weigh those sort of things and do that using the math. Okay, so far so good. Are you glad you have a graphing calculator for things like that? Yes, we are. Okay, now all of these are called continuous functions or continuous graphs. So at the bottom, I copied what's called the key concept, okay? Continuous means that they just keep running, right? In a cement mixer truck, you can have 1 pound, 2 pounds, 3 pounds of cement, but can you have 1.1 pounds of cement? Or 1.2, 1.25? You can have everything in between. But some things are called discrete graphs. So we can use our calculator to help us, right? But your calculator is not going to make a discrete graph. It's automatically going to assume that it's continuous. But for example, a discrete thing might be if you go to the store and you want to buy 5 bags of chips, right? Can you buy 5.5 bags of chips? Can you take half of a bag out and put it back on the shelf and go, I only want 5.5 bags? That's really what we call a discrete function. You can buy 1 bag, 2 bags, 3 bags. You cannot buy 3.5 bags of chips and just tell the store, I don't have enough for 4 to buy 4 bags, so I'll pay you for 3.5, but I'll leave half the bag of chips here. Great, right? That's technically discrete. You have distinct spots. Okay, so almost done. So on this one, we're not going to do the whole thing, but I want you to think about this, right? And tell me which it is, okay? So it says a local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation, graph each function. Is the graph continuous or discrete? Okay, so we're going to use like a quick method here. All right, a gallon of milk makes 16 ounces of cheddar cheese. Okay, each wheel of cheese costs $9. Okay, one of these is discrete, meaning separate, and one of them is continuous. Which is which? Okay, so the gallon of milk makes 16 ounces of cheddar cheese. Is that continuous or is it discrete? It's continuous, because what if you only use a half gallon of milk? How much are you going to make? Right? So you can make different amounts. So this one is continuous. Is he going to sell you half a block of cheese? Probably not. Some places will, right? Some places, if you go to the deli counter, you can get half pounds of cheese and stuff, but let's assume he's selling them by the whole wheel. This one is called discrete. Now, let's write a rule for this. 1 gallon of milk makes 16 ounces of cheddar cheese, right? So y equals, right? What's our rate of change here?
16.
Yep. Okay. So 1 gallon of milk, right, makes 16 ounces of cheese. Let's think about that a second. So maybe it'll help us, right? So if you have 1 gallon of milk, it makes 16 ounces of cheese. If you have 2 gallons of milk, how much is it going to make? 32 ounces of cheese. If you have 3 gallons of milk, how much is it going to make?
Oh, 2. Wait, no.
40 what? 32, 42, 48, right? Okay. So this is continuous. What's our rate of change here? What's it going up by each time? 16, right? All right. So 16 x, right? Okay. What's our starting amount? Okay. All right. No. Think about it, right? 0, right? If you make 0, if you use 0 gallons of milk, how much cheese are you going to make? 0. Okay, so that's the unspoken one. So you can put plus 0 there. You don't have to. All right, this one, what's our function here? Y equals what? 9x. Starting at 0 again, right? If you pay $0, how much cheese are you going to get? 0, okay? Now, the difference, let's see, right? In your calculator, go back to your window. We got to change it again. All right, think about the window here, right? Oh, sorry. All right, so let's do 16x. So we're going to have a minimum of 0, right? Our maximum, we can leave that, let's make it 10, right? And go by ones. Our y minimum is going to be 0 again, but our maximum is not going to be 60,000. We're not going to have 60,000 ounces of cheese. I mean, some of us would like 60,000 ounces of cheese, but okay. Let's just go. Let's do 100 here. All right, and we can go by tens. Okay, press graph. Oh, hold on. We got to change our y equals. So put in our y equals 16x. And then let's hit graph. So it graphed the continuous function, didn't it? Right? Okay. So this one, we could graph very easily. Let's pretend we're just sketching it, right? So let's go ahead, sketch it out. Boop. Right? It's going to start right here at 0, 0. And like we can use, let's get at least one more spot, hit, we got to change our table again. We don't want to go by 20s, right? Let's start at 0, hit second table set, start at 0. Let's just go by ones again. All right, now hit table. All right, so yeah, so at 1, what do you want to go by here? Probably we can go, but can we go by 16s? 32, 48. All right, so at 1, you got 16 ounces. At 2, you got 32. And this is going to connect, right? Like that. Okay, let's do the other one now. Y equals 9x. Oops. Okay, we're still fine here, right? And our window probably is fine. Why is this not an accurate graph? Even though we used our calculator. This is not the correct graph. This is the correct graph for this. I can still do this. I can still go like this. All right, I can still go by ones here. Right? I can still start it at 0, 0. What would be a good, can I go by 9s here? Yeah. So let's 9, 18. Okay. All right. I can still use my table and figure out that this is 0, 0. This is 1, 9. This would be 2, 18. This would be 3, 27. But this is not the right graph. But is this the right graph?
Yes.
Should I draw a line through it?
Yes. No.
Why not?
Because it's not discrete.
It's discrete. Okay? Because you're only going to buy 1 block of cheese. You're not going to buy 1.5 blocks, right? 2. So this is an accurate, your graphing calculator, unfortunately, is not going to make the discrete graphs. That's something you're going to have to know in your mind. It gives you the values, the correct values in your table, and I want you to use that. All right? But like when we're talking about a discrete graph, you got to make sure that you make it discrete. Okay, the last stuff is so easy. Look at this. But I do need to show you on your calculator how to get this. All right, ready? So we're going to change our window. What I want your window to be right now is the standard window. -10 minimum, +10 maximum, and then same for a y, -10 minimum and +10 maximum, and then a scale of 1. I'll leave it up there a second.
What's the very bottom one mean?
The resolution, you know what? I'm not even really sure about that. I'd have to look that up. Okay, ready? So the last thing that I just need to teach you is like how to do accurate graphs. If they don't ask you for a table, right? And they just say, what is the graph? You use your calculator. And this is what you could have done on the first one too, but I had to show you what to do a table if you didn't have it. Here's what you do. So we're going to go to y equals, clear out our 9x. All right, this is an absolute value symbol. All right, that's not in there. And now I've got to remember where it is. I believe it's under math. Yes, it is. Okay, so go to y equals, math, go press math. See it? Oh, I'm sorry, my finger's not on there. Math is under the alpha key. All right, does everyone have this screen? Okay, so this is where some of your stuff is going to be, but the rest of it is under NUM, which stands for number, and ABS is absolute value. Okay, so press enter. ABS, and then we're going to put X and the parenthesis, and then -4. Now, depending on how new your calculator is, yours might look different. It might actually put in absolute value lines in it, but I have an older version. All right, so some of you, does someone have a newer calculator that I can put under screen real quick? All right, so the newer calculator should put the absolute value lines in it. Does everyone have that? Then make sure you're on the outside, because look at the minus signs on the outside of this before you then press -4. Okay? Good. Now, when no matter what, if you have an older one or not, when I press graph, it should look the same. Okay. Now, the important things that we're going to put on this graph, right, are going to be the vertex. This we need to know where it is. How can I know where exactly that is? What should I go to?